All right, so Chapter 12, Lesson 4 is Shape of Data Distributions. Here, first thing I want you to do is I want you to write your definition in your spiral for the distribution. The distribution of a set of data shows the arrangement of data values. The words show some of the ways the distribution of the data can be described. Match the words below to their definitions. So we want to match the words with their definitions. So let's see. The left side of the distribution looks like the right side. If the left side looks just like the right side, it is symmetric, right? So that is symmetry. Very good. The cluster, well, let's see. The numbers that have no data value. There's nothing in that section.
Yeah.
That's a gap. Very good. So that's the gap. The most frequently occurring values are the mode. What happens there when you're looking at it in a diagram? It's a peak. Very good. And then lastly, data that are grouped closely together, they are clusters. Very good. So there is your vocabulary. So next we want to describe the shape of a distribution. Please make sure you write down your heading. Make sure you write down your heading. And write down your highlighted definitions. So, symmetric distribution is data that are evenly, actually, you've already written these down, right? In your warm-up, okay? So symmetric distribution is data that are evenly distributed between the left side and the right side, okay? The distribution shown here has a cluster, and a cluster is several data values within the interval, and that's between 10 and 12, okay? So that is where the cluster is. Does everybody see that? There are gaps at 9 and 13. There are the gaps where there's no data values. And there is a peak at 10 because it is the most frequently occurring value. So there's where the peak is. So for example 1, it says the line plot shows the temperature in degrees Fahrenheit in a city over several days. Okay? We want to describe the shape of each distribution. Well, first, you can see that, is it the same on the left and the right? No, it's not the same on the left and the right, so there is no symmetry. So it is not symmetric. Okay? There is a gap. There is a gap between 19 and 21. And there are clusters. There are clusters from 16 to 18 and from 22 to 25. Okay? It has a peak at 22. That's the mode. It's where you have the highest column. And you can see there are no outliers. Does everybody see that? And that's how you describe the distribution. For example 2, it says the box plot shows the number of visitors to a gift shop in 1 month. And we want to again describe the distribution. So here, in a box plot, can I identify gaps, peaks, and clusters? No, we can't identify any of those on a box plot. Okay? Let's see. Each box plot and with box and whisker has the same length. Does everybody see that? They're both 20. So the data is evenly distributed. The distribution is symmetric since the left side looks just like the right side. And you can see there are no outliers. Remember, on a box and whisker plot, the way we show the outliers is a little asterisk on the outside. Does everybody see that? Everybody understand that? Remember? We would have, if we had an outlier, it would be like a little asterisk out there, right? Okay. So for this histogram, we want to use clusters, gaps, peaks, and outliers, and symmetry to describe the shape of the distribution at the right. Okay, so first, let's look at symmetry. Is it symmetric? Both the same on both sides? No, it's not the same on both sides. So the shape of the distribution is not symmetric. Okay, please make sure you write this down. You can take from your notes, you can cut out in the textbook, you can cut out the histogram and tape it into your spiral, just so you have that in there, so you know what you're describing, okay? How about clusters, gaps, and peaks? All right, so here, there is a cluster from 1 second to 7 minutes and 30 seconds. The distribution has a peak on the left side of the data at 1 second to 2 minutes and 30 seconds. And finally, there are no gaps and no outliers. So now we're looking at the measures of center and the spread. Okay? So it says here, use the following flowchart to decide which measure of center and spread are most appropriate to describe a data distribution. Okay? So first thing we want to ask ourselves, you make sure you write down this flowchart, okay? First thing we want to ask ourselves, this is the measures of center and spread, okay? First thing we want to ask ourselves is the data distribution symmetric? If it is symmetric, then the best measure of center to use to describe the spread is the mean or the mean absolute deviation. We're going to use the mean to describe the center, and we'll use the mean absolute deviation to describe the spread. How is it dispersed? Okay, how is the data spread out? Okay. If the data distribution is not symmetric, then the best measure of center and variation, we're going to use the median to describe the center, and we'll use the interquartile range to describe the spread. Okay? If there's an outlier, the distribution is usually not symmetric. Okay? If we have an outlier, it's usually not the same on both sides. So for example 3, it says the line plot shows the number of states visited by students in a class. We want to A, choose the appropriate measure to describe the center and spread of the distribution. And then we want to justify our response based on the shape of the distribution. So first of all, we're going to ask ourselves, is it symmetric? No, it is not symmetric. So what am I going to use to describe the center, the measure of center? That's going to be the median, right? And what am I going to use to describe the variation? The interquartile range. Very good. So the data are not symmetric, and there is an outlier, 19. So the median and the interquartile range are appropriate measures to use. Very good. So here, the second thing we're going to do is we're going to write a few sentences describing the center and the spread of the distribution. Okay? So that means that we have to find the measures of center that we're using, and we have to find the measure of variation. So the median is 12 states. The first quartile is 11, and the third quartile is 13, so 13 minus 11 gives us the interquartile range, which is 2 states. So the data are centered around 12 states, and the spread of the data around the center is about 2 states. So for this guide, we want to choose the appropriate measure to describe the center and the spread of the distribution. We want to justify our response based on the shape of the distribution, then describe the center and spread. So the first thing, remember what's the first question we're going to ask ourselves? Is it symmetric? Very good. So is it symmetric? Yes. So that means we're going to use which ones for the measure of center? The mean. Very good. We'll use the mean for the measure of center. And what will we use for the measure of variation? The mean absolute deviation. Very good. So the first thing we want to do is we want to find our mean. So here is our mean. So the mean, with a dot plot, we can add up all the data. Remember, that's going to be 25 plus 26 times 2 and 27 times 2, and we'll add those all together. We get 696, and there's 24 pieces of data. So we're going to divide by 24, so we get 29. The next thing we're going to do is we're going to find our mean absolute deviation. So we have our mean. The next step in finding the mean absolute deviation is finding the differences, right? We're going to find the differences. So here are our differences. Now, look at the way I did these, you guys, okay? Here, because there were two 26s, the difference between 29 and 26 is 3, but there's 2 of them, right? So I just multiply times 2. Does everybody see that? Let's see if I can get this highlighted to work. So we found our differences, and now we want to find the mean of the differences, which gives us our mean absolute deviation. So our mean absolute deviation is 1.7. So here's the description. It says, because the data is symmetric, let me move this up a little bit. Because the data is symmetric, the appropriate measures to describe the data are the mean and the mean absolute deviation. So this is what we found up here. There are no outliers, and the data are centered around the mean of 29 years. The spread of the data around the center is about 1.7 years, which is the mean absolute deviation. Does everybody understand that? So here is the mean. The mean absolute deviation is about 1 and then maybe around 1.7. So this area right here is where most of the data is. So we can actually, we don't need, huh? Oh, it's on freeze. Sorry. Why not freeze it? So here's where the mean is, in here, and then this is where most of the data, see where my arrow is? That's where most of my data is centered.